Hello students, in this lesson we are going to discuss the topic exponents. So let's begin our day 7 challenge, which is all about exponents or otherwise called as indices. So if you have not done any of our previous day challenges, please go back to the previous videos, complete the problems and then you can start here. Now coming to exponents, what are exponents? Before I answer this question, I have a small question for you. How do you read this number that is there in the red? And give your answers without fail. I know some of you might be feeling difficult here to read this number. And we certainly use such numbers in our daily lives to, say for example, measure the distance between Earth and Jupiter. Or while measuring the size of very minute organisms like amoeba, we use such low numbers. So representing these numbers and reading them is really a difficult task. In order to ease that, in order to read and write such numbers, such huge numbers as well as such very small numbers, we use exponents. So how do we write this number? It can be written as 64 multiplied by 10 raised to the power of 18. Okay, because we have 18 zeros in that number, we can write it as 10 raised to the power 18, and 18 is called as the exponent here. And let's dive a little more deeper about exponents. We all know repeated addition. Repeated addition is nothing but our multiplication. Say for example, if the number 3 is added 5 times, then we say 5 times 3, which gives us 50. If instead of a number we have a variable, then we say that x added 5 times and we get 5x, which is nothing but 5 multiplied by x. So repeated addition is basically your multiplication. In the same way, repeated multiplication is nothing but your exponents. So say for example, 3 here is multiplied 5 times. So it can be represented as 3 to the power of 5. The 5 denotes how many times we are multiplying. Say for example, the variable a. It is multiplied 5 times here. So we can write it as a to the power of 5. So basically exponents are nothing but repeated multiplication. So in the previous example also, we saw that 10 to the power of 18. It means that 10 is multiplied 18 times. So this is the very basic of an exponent. So let's see what is the general form of an exponent. It is usually written in the form of a to the power of m. So what is this a? A is a real number which is called as base. Real number means a can take any value like natural number, whole number, integers, rational numbers as well as irrational numbers. And what are this m? M is a rational number, which means it can take natural values, natural numbers, whole numbers, integers and anything in the form of p by q. It cannot take an irrational number. So the other name of this exponent is, m is called exponent here. The other name for it is power or index. The plural form of index is indices. So generally we say exponents or indices. Okay, I hope you're clear with the basic terms here. Now let's dive into certain laws of exponents which are very important to solve the problems. The laws are nothing but a shortcut or a pattern or a rule to solve the exponents problems easily and quickly, right? So let's see the very first law of exponent, which is your product law. Product law is nothing but if two numbers are multiplied, say for example, a to the power of m is multiplied by a to the power of n, then it can be written as a to the power of m plus n, which means when the same bases, you have to note here, when the same bases are multiplied, the power will get added. Say for example, 2 to the power of 2 is multiplied with 2 to the power of 3. So it means 2 times 2. 2 to the power 2 means 2 times 2 is again multiplied with 2 times 2 times 3. 2 to the power of 3. So basically how many 2? 5. So 2 to the power of 5. This is nothing but adding the powers 2 plus 3. So when the same bases are multiplied, the power will get added. This is our very first law, which is the product law or product of powers. The next law is the quotient law. Quotient means the result of division, right? So if same bases are divided like this, then the power will get subtracted like this. Say for example, the same one, 2 to the power of 3 divided by 2 to the power of 2. So 2 to the power of 3 means 2 times 2 times 2 divided by 2 to the power of 2, which is 2 times 2. So cancel out. You get only 2, which is nothing but 2 to the power of 1. This is basically 3 minus 2. The power gets subtracted. So always remember again, when the same base, not different base, same bases are divided, the power will get subtracted. The third law is power law or power of a power. So what does mean by that? We already have a power that is again raised to a power. In such cases, we can just multiply both the powers, m times n. So say for example, 2 to the power of 3 is raised to the power 2, which means 2 to the power of 3 is repeating 2 times. Multiply 2 times. So we already know through our product law, when the same bases are multiplied, power will get added. So 2 to the power of 3 plus 3, which is 2 to the power of 6, which is nothing but multiplying this 2 and 3. 2 times 3 gives you 6. So you can directly write this answer without all the steps. So it literally saves your time. And coming to the next part, next law, which is the power of the product. What is my product? The result of multiplication. So product, let's take a product A into B. And this is raised to the power m. If this is the case, then we can separate them both. A to the power of m multiplied by, this dot denotes multiplication, b to the power of m. Say for example, 6 to the power of 2. 6 is nothing but 2 times 3 to the whole power of 2. So 2 to the power of 2 multiplied by 3 to the power of 2 using our power of a product, right? Then again, 2 to the power of 2 is 4 and 3 to the power of 2 is 9. So it basically gives you 36, which is same as 6 to the power of 2. So in the problem, based on the problem, you have to choose whether you need to apply AB to the power of m, or you have to separate into two forms like a to the power of m into b to the power of m. This also simplifies your problem easily. Okay. The next law is the power of a quotient. Just the same law like before, but here instead of a product, we get the quotient. If this is the number, then you can separate it as a to the power of m by b to the power of m. Say for example, 2 by 3, the whole square means either you can solve with this. If not, you can split it into two forms, 2 to the power of 2 divided by 3 to the power of 2, which gives you 4 by 9. So based on the problem, you have to choose which form you have to use, whether this form, writing it separately, or as a whole power. Okay, this is the power of a quotient. Another important law is the inverse law, which is 1 by a to the power of n. You can bring this power, the number with the power, to the numerator like this, but the sign changes. The sign of the power changes. So basically 1 by a to the power of n is equal to a to the power of minus n. So what does that minus denote? It denotes the position of that entire number. If it is negative, it means that it is not supposed to be in that position. It has to come to the other side. Say for example, in the numerator, if you have this negative sign, it means that the actual number supposed to be there in the denominator. If in the denominator you have a negative power, it means that the number has to go to the numerator, vice versa. That is 1 by 2 to the power of 3 is equal to 2 to the power of minus 3. The same way, if you have a number like 3 to the power of minus 4, It means that it's not supposed to be in the numerator. It has to come to the denominator with the power. Okay. So all these laws are very simple and very effective to use in your problems because it reduces your time and helps you to solve it quickly and efficiently. Right? I hope you understand all the 6 laws. Now, apart from the 6 laws, you need to know certain other things which are this. A to the power of 0 is equal to 1. That means any number raised to the power 0 is 1 except 0, because 0 to the power 0 means nothing raised to the power nothing, which gives you an undefined answer. So except this, any number raised to the power 0 gives you the answer 1. The next is a negative number raised to the even power always gives you a positive answer. Because since the power is even, all the negative signs will pair up and it will always give you a positive answer. In case if the negative number is raised to an odd power, then you will get a negative answer. Right? And if x to the power of m is equal to the x to the power of n, it means that both the bases are same and both are equal. It means that the power also has to be the same. Okay? And remember, this x, the base should not be equal to 1 and it cannot be equal to 0. The next one is x raised to the power m and will be equal to y raised to the power m. The bases are different but still they are equal, means whenever m is odd. Say for example, 2 to the power of 3 will be equal to 2 to the power of 3 only. Suppose if this is written as y, suppose you need to find y. If the same basis and it is odd, then obviously y has to be 2 only. Okay, it can't be negative 2 or any other number. Because both are equal, y has to be 2. So these last three identities will be helpful for you to find the unknowns in the problem. And similarly, x to the power of m will be equal to y to the power of m. When m is even, then the answer will be x equal to both plus or minus y. How do I say this? Say for example, 2 to the power of 2 will be equal to y to the power of 2. They are asking you to find y. In this case, since the power is even, y can be both plus 2 as well as minus 2, because both these answers will give you the same answer. Because power will even, so both the negatives will pair up. Whenever the power is even, you have to understand that y can be either positive or negative. Okay. So these are the basic laws that you have to keep in mind while solving the problems on exponents. So hope you understood till now. Now the real task for you, which is the math challenge 7. The problem 1 is simplification, which means you have to apply all the laws that are discussed so far and solve it and bring it to the simplest form. The problem 2 is finding the unknown. So you have to apply the laws that we have discussed so far and apply the last few things that we discussed and find the value of n here. Okay. Complete the problems and post your answers. Let's see the answers of these questions in our next video. Okay. I hope you will give the answers. And if you like the content, please give a like button and subscribe to our channel for more such valuable lessons. Thank you.